In the previous video, Introduction to Pragmatic Gen AI, I have explained what is RAG, where how it will take the external sources and then how it will chunk, and then with the embedding model which we used earlier like sentence transformer, and then how it will generate the embeddings and store in vector database from a user query. Again it will use same embedding models, then generate embedding for that, and it will do a similarity search in easy words matrix vector multiplication or a matrix multiplication, then take top 2 or top k documents, and then it will get a context based on the based on the prompt we provide, and then with the question and this augmented data it will generate the answer. In this session we will mainly focus on internal document, and we will start with only one document, that is PDF. And consider in this PDF we have a PDF of pain medicine guide. In that you will have pages 1 2 3 pages, and inside the pages you will have a content of it. Now what how does it create a chunks? So what it will do, it will go to the, it will take the text out of the PDF pages, and for a text what it will do, it will create like example chunk 1, chunk 2, chunk 3, like that, chunk 4, chunk 5, chunk 6, like that. And consider if there is a huge chunk, might be here given only 500 tokens or 500 words, so it might chunk like this, or half of it will do a chunking. So here it has provided a chunking, and what you want out of a chunk is 2 or 3 sentences. And you have observed already here it is not chunking properly in a paragraphs. How to chunk properly, which model to use, and what you have to give a settings like what is the chunk overlap, chunk size and all. This I will make another detailed video how to chunk the documents properly. But now focus on what exactly the data ingestion process is going on, and we will focus on first all the terminologies, and then we will go in depth and build our own application, and even I will explain how we have to build and with a code also. So now you chunked this pain medicine guide, all the pages, then you have the vector database of medicine guide. Yes, so you will build this RAG, and you will check with some of the examples. Before that, what happens, one of your friend will call on a weekend party for his birthday. So what you do, you will leave as it is and you will go to the party. Then after having a party in the morning, you will try to understand what is happening inside the RAG, and then you will get a severe headache and your head will be rotating. So instead of going through what is inside RAG, what you will do, you will ask, hey, already I have developed a RAG which is related to pain medicine guide. Let me ask a question and we'll see how it will give a result. Then you will ask a query. I have a headache and I don't have a painkiller and I have Dolo 650. As you know, Dolo 650 is famous in Corona days. And I will ask, can I take it now? So what it will do, it is your query now. Okay. So now once you ask a query, then what it will do with embedding model, it will generate a embedding for your query. Once it generate a embedding for your query, then from the vector database, what it will do, it will search a similarity search, and based on that it will give top 2. So here in vector database you have already have this PDF, you have chunks in that and embeddings of that. Example in FAQ or somewhere your chunk got hits and it gave the results of top 2. Okay, and then your RAG with your prompt and everything, it gave yes, Dolo 650 also mild painkiller and take with full glass of water after food. Then you will see, oh, whatever I built, I have got some answer out of it. Then you will feel proud, but wait for the next terminology. Yes, your RAG has provided an answer. So do you take it medicine immediately or do you go for a doctor prescription? But is there anything it has to tell? Like example, whatever it got in FAQ, it hit here, and some how to use it, it hit here, and then up top to or like semantically related, it gave the answer, but it doesn't know what you did in the party, why you are getting the headache. It doesn't know that context, okay? But if it only hits here, and there is a lot of information in this document and in this embeddings and check, but it didn't provide. So is there any other approach or a principle so which will remove this limitation from the RAG? Now you asked question about can I take a Dolo 650 where it will be in medicine and names. It might be here as a Dolo 650 and brand how to take it and all, it will hit here. And then there is something in FAQ, it is information about whether it is a painkiller or not, and when this is a painkiller, and it will understand what is the definition of it, and then it will take here how to use a medicine and what you should not, when you should not take. That also example, drinking alcohol or a hangover, paracetamol plus alcohol is a liver damage, and when to take it, it's already answered from here, but we didn't get complete answer. So how another approach should work, right? So it should go here, then it will understand, it got the information here, and then it will take from FAQ, and from FAQ it should understand what is the definition, and from again how to take a medicine, and then it has to go to what, when to not to take it, and then it has to go to when to take it and what is the timing put and all these information to be provided. By seeing this, whatever the markings I am provided, right, do you think like a graph? Okay, it is here and then it has to move here, traverse to this, and it has to traverse from child to parent, and parent is whatever the nodes are there inside this node, whether information is here or not here and here. So basic thing what we have to develop out of RAG, right? RAG will stop once it got an answer. But GraphRAG is something like that. It will hit it nodes. You can configure these, how many nodes it has to go, how many information it has to know. So this process is called GraphRAG. So now once you build this GraphRAG, then what your answer should look like? Yes, Dolo 650 is a painkiller from here, and how to take it. Yes, I got the information, and put timing you got, and safety warning, and it got the all answer, liver damage risk and all. So now we know about what is RAG and what is limitation and what is graph RAG and how it will take the information and how the RAG is improved with the graph RAG. But also assume that for a simple question, it is going to all nodes and it is getting the information. How much time it will take to give answer? You should go here and fetch the information to the RAG retrieval and give you again. So another limitation of this graph RAG is also, right, latency. Latency is the next word we were trying to understand. What is latency in the Gen AI? Latency is nothing but when you ask a user question and when your agent or when your chatbot will provide your answer, this timing difference is called latency. Means what happens? Yeah, for accuracy and for graph traversal, I can go to the GraphRAG. But what if it, example, my RAG will give output in like very fraction of second, like let us consider 300 millisecond, okay? But what this GraphRAG might give me the response because it has to do multiple retrieval and do a RAG, go to the all graphs and all, it might give me around 800 milliseconds. Okay, this is the main limitation of GraphRAG. And then we have go to the another process and we will list down with respect to, we will benchmark them, what is the latency, accuracy, when to use GraphRAG, when to use RAG, and all these things we will go in this course. So GraphRAG has provided the output based on from the subsection. It will go to the page links, and wherever related again it will go to another page and it will give the answer. So now we will try with the new query and check how it works. So I will ask, I took a crossing 2 hours ago. Can I take Dolo now for the headache? So you see, Crossing and Dolo are the uh, two brands. And then if I ask this question, what this particular GraphRAG will do, GraphRAG still treats Dolo and Crossing as just words. I will repeat it. It will consider just as words. It doesn't know both are same medicine. So what it will do for crossing, it will go to the pages, get the data, and Dolo, it will go to the page, get the data, and then it will provide the output. Dolo contains paracetamol, Crocin also contains paracetamol, and it will provide the standard dose. Here you have to observe one thing, it doesn't automatically say both are same drug, and it doesn't calculate automatically, and even if it calculate it will take a time to calculate it, and doesn't conclude stop overdosage risk. So here you need to understand one thing, what if already this graph has some intelligence or has some process which should know Crocin and Dolo both are the same medicines. So how do you do this? What is the process which does this? So there is something called entities. So example, as from the previous example and PDF I have shown. So what it does, entity means you can consider it as entity is a single, a unique and well-defined thing or a concept, or you can just consider it as a node. So what we will do from the previous PDF example, we will see what all the entities can be. Example, first one is brand name. Okay, in this brand name, the entity is Dolo 650 and it will have its type, properties, and where it manufactured, from, strength, and even relationships. Okay. Similarly, Crocin also have brand properties, and the relationship is a brand of paracetamol. Even this is a brand of paracetamol. And the next entity we can consider as a generic drug. So where it will have a entity called paracetamol, and it will have another entities which it will treats. Example, headache, fever, and body pain, and effectiveness, and onset, and first line mechanism. These are all the entities you can create. And then we will have something called rule entities. What these rule entities will do, example, minimum gap rule and maximum dosage rule. So these rule entities, what are safety rules, where it will mention how many hours you have to take tablet. Once you take what is the next time, what is the gap you have to provide, and it will have this logic. Please remember this logic. The safety rules entities will have a logical rules, and even it has a relationships. And even for maximum dosage, how much dosage you can give, and similarly you will have the violation risk and logic inside that, and relationship. Okay, now we will have another entity called risk entities. So what is the drug can do a risk for you? So in that risk entities we will have what is the severity of that and cause of severity, and then you have another called entity called liver risk. This is about alcohol risk. If you take that drug, is that with along with alcohol, what it can cause you, and even for a liver. So now you have seen these entities. So earlier what GraphRAG was doing, GraphRAG was just taking from which subsection of page to which page and how it is related, and it is considering your question as a word, and it is trying to get the information, and then it will trying to provide the answer. Now what it will do, example Dolo is a entity, right? Here is a brand of paracetamol, no? So what it will do, it will connect it to this entity, and even is Crocin is a brand of paracetamol, so both are same entities of paracetamol. Okay, and then drug rules, after once you get this entity and it is related, it is connected to the rule entities. Yes, and then whatever the risk it can create, it will connect to this alcohol risk and liver risk. So now you can see, now it instead of pages to the subsections or number of pages, PDF pages and all, it is connecting through the entities, and it is building the relationship of entities. Okay, so instead of page and all, it will building the relation of entities, and along with that it is having a decision logic with the rules. In a rules entities it is have a decision logic, if this is and then, and this whatever the process it is doing, right? Once you have vector database, from this entities relationship rules decision logic everything, it has some intelligence, consider that, and then it will create a knowledge database. What database? It will have the all entities and its relationships, that is called knowledge database. Okay, once you see, earlier RAG and GraphRAG have just going through the vector database and it is trying to give the answer. Now here it will create its own knowledge database, means based on your PDFs or whatever document you give, based on that it will create its own knowledge database, means it will have a knowledge of each word and how they are related, everything it will be having with this knowledge database. And this entire process we will call as knowledge augmented generation. Just K has a new word, earlier it was R, means retrieval, just a retrieval. Here you have a knowledge augmented generation. Now we will understand all these approaches together in a one slide. So the architectures RAG, GraphRAG and KAG. Okay, so semantic search, right? Every approach has a ability to do a semantic search. So understanding the meaning of the words or sentences, it will retrieve, and then document structure relationship. This is not present in a RAG. This will be done through the GraphRAG, like which page subsection and for which it is connected to which page and which PDF, and those hierarchical approach how the graph is generated will be done through the GraphRAG, and even KAG will have a GraphRAG, and then entity relationship graph. as you mentioned, as we have seen, right, dolo and crossing, right? For those dolo and crossing, this will consider it as a word and it will go through every document and search. But this KAG will create the entities, and along with that, each entity, how they are connected, that it will build a relationship. Okay, then entity equivalence also it will create, even structured properties like max dosage, minimum gap, and typed relationship, whether which one it will treat, and sorry, and even with the contradicted with also it can provide, and rule definitions as a data, as I mentioned, right, rules like if this drug if you take, what is your uh, risk, and what is your safety critical, everything if, and it will be mainly, I would say it is a decision rules. You can consider if and then multi-hop traversal and foundation for reasoning. Now after this, these all will be given to the LLM with a prompt, and where you can add the reasoning model also, where you will have not structured data, means it will give the top k documents which doesn't have a structured data, and it will provide the link to the pages, subsections, and where it is. So by that it will, reasoning model can go inside that and search again and provide you the results. But here in KAG you have entities and rules, with that you can easily build a reasoning model. And building a reasoning agent complexity, as I mentioned, as it is not a structured data, it is top k, you have to build manually, and which will be, complexity will be very high, and for this is medium manual entities, and this is very low. So the reasoning model out of the KAG you can build easily. Now consider you have built RAG, GraphRAG and KAG, and based on that or a hybrid approach you have built your chatbot applications. So what you will do, as a user, you have asked, I have a headache, I don't have a painkiller, I have $650, can I take it for now? So what it does is, with your hybrid approach, or you can choose any one of them, RAG, GraphRAG and KAG, based on your scenarios and requirements, you can choose it. So what it will do, it will do the process, and then what it will do, it will store in a memory with respect to your question and answer. If you are storing it in a memory, if it will save in question and answer inside your memory. So what happened, you said this story that you are having a headache, and to your friend, then what your friend will do, he will take your chatbot and he will ask a question differently, like my friend is having a headache, can he take a dolo 650? So these are semantically related. So then what happened again, he will tell to your friend, then he will ask, can I take a dolo for headache? So even if you see, this is also semantically almost similar. So after that, one unknown guy where you are shared a chatbot your application, and you are all from the same party, right? So we don't know what happened there. He will also ask a question. Does Dolo reduces a headache? Can I take it? So these all queries are almost similar. So do you build, or do you provide your RAG or GraphRAG or KAG for each queries which are already asked and stored? You want to do it again. It will increase your cost time, response time and latency. Every time it has to go to the document, fetch the answer and provide the answer. So for these situations, like example, your chatbot is just for 5 users. Let us consider you have made it as a product, and there are like 10,000 asking. If they are asking the same question, what do you do? Do you retrieve every time, or do you retrieve every time, or do you go to the all graphs and check it and give the answer, or knowledge graphs and give the generate the answer? No, right? So what will you do here? So then you use the utilization of cache memory. So whatever you stored, you will store in a cache memory. And if the questions are related or semantically related, what you can do, you don't need to retrieve everything. What you can do from cache memory, just provide the answer. And this answer will be same for everyone. This process is called cache-augmented generation. But it has its own limitation. What is the limitation here is, whenever the user asks a query and consider if he has asked a query and it answered and everything is right. But what if your PDF document itself has updated? What if your vector database has updated? It has a different answer, means it has a different content inside it. So then if you provide this answer, then that absolutely wrong. So you are giving a wrong information which is not in the latest or updated vector database. So this is the main limitation of this KAG. Now we have understood RAG, GraphRAG, KAG, and last SAG. Now we will benchmark all them together. Benchmarking again. What is benchmarking? Comparing these architectures or LLMs, whatever it is, with the metrics. This is called benchmarking. So now you can see here RAG, GraphRAG, KAG and SAG. As I mentioned earlier, core features, everyone already knows these core features, and here in SAG you just need to understand this applying logic rules also be okay if it is having the KAG. So these all the things I didn't fill because based on which you choose, because this is very used in mainly when there is traffic overload or something, then you will use a KAG or a same similar semantic questions, then you will use, no. So that's why I didn't mention these things. And query caching, that will be done through KAG. And if you consider performance, okay, speed of the first query, okay, once you do RAG it is 2 seconds, and graph RAG you see it is increased because it has to understand entire graphs, links and all, and then it is increased. And for KAG still it is increased than GraphRAG because you have to create knowledge database and then it has to understand everything, and it will be increased. But if you see here for SAG with respect to KAG I had given, it will be almost same when you are doing it for the first time, because the query will get retrieved from RAG, GraphRAG or KAG and stored in cache memory. Then if you repeat the query, then it got reduced. After these two steps, whatever the query you can ask, right, then always cost will be zero because it is taking from a cache memory and it is giving you the results. Then coming to a complexity, as I mentioned, the KAG knowledge augmented generation cost will be more, and then this will be less than that, this will be less than that, and easy setup is to KAG. And difficulty level or complexity will be as usual. Whenever you go from left to right, it will be increased till KAG, and the SAG will be the most easiest one. Okay, and the main thing you need to understand which is best for which scenario, where and all. If you are asking simple question and answer, then RAG plus SAG is the best combo. You don't need to build a graph rag because it will take a time and it will create a graphs and all. Then knowledge augmented generation is not at all required in this case. Okay. Then structured document. If you have a structured document, then It's okay, you can use with a good prompting and all, but the thing is perfect one is the GraphRAG. This will be a good and this will be good. If it is around healthcare, medical, or regarding your law constitution and all, then I would suggest you have to use KAG. This is the main advantage of here, knowledge augmented generation, because it will create entities and based on that it will give the responses. And when it is a high traffic, like there are, as I mentioned, right, in cloud you hosted and there is a huge traffic, then you just need to use cache memory results for that. And the answer quality, accuracy will be good, better, best, complex, completeness will be always good for CAG and GraphRAG. Sorry, not CAG, CAG, knowledge augmented generation, and safety checks. This is the best one, but you can use uh, these for accuracy or continuous retrieval, and unless until it get a result you can do it, but partially you can build it also. Means what I meant by partially means once you have a query, it will have 5 subqueries. What you can do, you have to retrieve one, retrieve second, retrieve third, and all these again you can give to another LLM, and that will provide you a completeness. You can achieve through another approaches. I will go to mention in the next session. I mainly speak about which is that approach. And in one line summary, I would say this will be fast and cheap and complete context, and this has a smart reasoning and speed and cost saving. So here you have learned about all the architectures which are built behind the applications which you are using currently, Perplexity, uh, ChatGTP and all. This is the approach what those guys are doing behind the scenes with LLM and trying to give you the results.